All right, my macro friends, let's have some fun with a dynamic empirical model in Excel. Small share screen, because I want to show you something. What if you could go in and change one of the cells inside of a macro model, and you can see how GDP, inflation, real and nominal rates would all respond to a shock? What if you can see how consumption, investment, government spending, net exports would all vary their shares and contributions? That's what this is going to do for you. So I want to take you on a little tour and then we're going to play with it. All right. So up at the top, B, C, D, and E, T minus one and T, yesterday and today, delta, percent delta, change, and percent change. We got our reduced form structure with the exogenous variables such as parameters, shocks, and the star variables. We talked all about how those things have to be constructed. They're given to you. Maybe we can calibrate. Equilibria. I know you love me because I did you a favor. I gave you the entire equilibrium structure inside of the Excel. If you're one of my students, you have it right now. If not, give me a call. I can get that to you. And each of the components of the model build on the rest. Now, with the nominal rate, that's not directly inside of our model. It's implied by our model. How is that? Fisher specification. Nominal is real plus inflation expectation. Sometimes people use actual, but we'll use the inflation expectation. You can use the gaps, y minus y star, pi minus pi star, r minus r star. Tells you how far you are away from that long run level. That's all reduced form. That's great because it gives you a summary, but you also need structural. So if I know the total level of economic activity, where does it come from? How is that split among its components, such as C, I, G, and X? Now, I'm going to focus on the structural decomposition of output. But you could have a structural decomposition for interest rates, for inflation. Think about the inflation basket, right? You could have on durable and non-durable goods, all different line items for interest rates, for different tenors, and all adding up to an average. We're going to focus on economic activity. So we've already discussed where consumption comes from, where investment comes from. We'll treat G as exogenous and X as exogenous, although we could treat it as components of X minus M, each one of them having their specifications. We'll treat as exogenous. Ba, 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 ba. I referenced all those pieces, add them up for T and T minus one. And then I take the percentage change. And then I take the shares in each period, and you can see consumption is around 60, 70%. And then I compute the contribution of C to GDP growth in a given period. And remember, you use yesterday's share times today's growth rate. It looks kind of unexciting, right? It's 100 and 100 and T minus 1 and T respectively. Well, why is that? Well, if you think about it, there's no shocks. And if there's no shocks, that means that we should be at the long run level. What's the long run level? Y star. And if we're at the long run level of output, we're at the long run level of inflation and real rates. And therefore, the nominal rates are just going to be the 2% on inflation target. And the real three, that's your five. So it's unexciting, but we can make it more exciting. So let's think about a shock. Let's say in period T, there's a epsilon IS shock. We talked about that before. That's in the IS curve, goods and services. A positive number means that it's going to be something that's beneficial to the economy. We'll ignore for now the amount because we talked about that in other settings, highlighted so that once you change it, if B is different than C column, it's highlighted in yellow. And did you notice? I'll do that a couple of times. Rewind the tape, slow it down, do 0.5 so it looks cool. See, there's a growth in economic activity, there's a growth in inflation, and there's a growth in interest rates. You know the intuition by now. If there's an increase in, let's say, government spending, which is captured by that reduced form IS curve, that means more economic activity, demand curve, outpacing supply curve. So there's an increase in inflation. The Fed sees that. So there's an increase in interest rates. And we know exactly how much. We could take a look at how our output gap, inflation gap, and interest rate gap change. And we can even go on down and we can see the contributions. You can see most of that change in GDP was due to the consumption, 0.27 percentage points. Investment actually fell because interest rates were rising. And then you can see how the compositions changed throughout. All right, so that works pretty darn well. And it makes intuitive sense, like we've talked about before. Here's a difficulty when we're using this type of structural specification. Um, okay, so you're with me on this. I add up 29, 36, 41, 44. I add up C, I, G, and NX. That should be equal to GDP. But it's not. I sound like Yogi Bear, right? It's not equal to GDP of the YEQ. Okay, so the reason for that is where did the C come from? Well, it came from that calibration. Where did I come from? That calibration. That doesn't mean they're disconnected. If you take a look at the specification, it is connected. Consumption, for example, is connected to Y. Consumption, for example, is connected to the interest rate. So think of it from the top down. If we hit epsilon through our reduced form, it trickles on down to consumption. But that doesn't mean that consumption is trickling back up. So it's not balanced in that way. That doesn't mean it's bad. It's just it's a unidirectional model. So we have something that's not balanced. How do I take a look at 187 and turn it into something that's analogous to 100 at the starting point, and 188 that's analogous to 100.89 in the period of the shock? Well, I need to scale. That's all. You're not going to change the slicing of the pie chart. All you're going to do is rescale it so it matches what your reduced form equilibrium should look like. So let me see if I can get that on one screen for you. One, come on, man. There you go. One screen, one screen. Technical difficulties. All right, I can't get it on one screen for you. I apologize. Should be flogged. There we go. So B18 divided by B47. Take the reduced form equilibrium of 100 divided by this induced structural component of 187. So that means that my reduced form is about half the amount, about half, 0.53 of the amount of what I got from this structural value. If C0 was different, that would be different, right? If any of the parameterizations were different, that would be different. But why would I want to do this? Well, let's go over here. I want all of these components to add up to what my reduced form model of 100 would say. So what I'm going to do is I'm going to take 123 times B48. I'm going to take that 123, which is the consumption in period T minus 1, and I'm going to multiply it by my scaling factor, by 50%. So I compressed it, reduced it, scaled it by about 50%. And I'm going to do the same thing for investment and G and NX, and that's going to give me 100. I'm going to do that also for period T, each one of them by their scaling components. That will give me rates of growth, same formula as before, and shares and percent contributions. So take a look at the shares. 65.8% was the share of the consumer for total GDP in period T minus 1 in my rescaled version. And hey, that looks familiar, right? So K3, 65.8% of total economic activity in period T minus 1, which means before the shock, was due to the consumer in my induced structural value. 23.6, 6.4, 4.3. 23.6, 6.4, 4.3. Why do they match? They're designed to match. I'm taking this big economic activity and its pie charts, and all I'm doing is compressing the size of the pie, but keeping the shares the same. That's the purpose of this, just so my reduced form matches the size of my structural. And as a result, I get my growth contributions and my rates of change. And each of those are represented all the way over here and all the way over there. All right, so we did a lot. We have a way to view the reduced form and the structural and make sure they're consistent with one another. But I want to show you a little shortcoming of this approach. Okay, doesn't mean it's bad, but I want to show you a shortcoming. So I'm going to get rid of that. And think about the story that I said to motivate the epsilon IS. I said, well, what if it was a change in government spending? President Trump is building the new ballroom in the White House. Well, what if it was used from taxpayer money and not from private donations? Then there would be some increase in government spending because they're hiring the contractors directly and such. Okay. Um, maybe I just want to say, well, rather than $12 million, maybe it was 13. Maybe you just want to put it right there. Okay, well, G went up. All right, well, something's wrong. Consumption didn't go up, investment didn't change, NX didn't change, and just GDP moved a little bit. We already know, right? When government spending changes, it's going to motivate IS curve. It's going to push out aggregate demand, which is going to increase economic activity. Oh boy, every time I've seen that happen, I know there's more inflation, which means the Fed changes rates, which means consumption is going to change and investment's going to change. But nothing happens here. Well, take a look at why. You, I'm the one who did it. I snuck into the structural model and I changed cell C41. All I did was sprinkle on magically a change in government spending. But that didn't change. And my equilibria didn't change. See, there's nothing here highlighted in yellow. So when I am trying to represent a structural change, if I'm moving that structural variable, I have to make sure that my reduced form model is consistent with that, not just in size with the pie chart, but also with the components of those shocks. So that's a shortcoming of this approach. Again, that doesn't mean that it's bad. All right, that doesn't mean that it's bad. I broke this, so let me put that back. Okay, so we can do this, and it bleeds down from reduced form to structural, but I can't do that. It doesn't work its way back up. Boom, boom. How do I do that? How do I fix it? So it does allow me, if you want, to change something in structural and see the reflection up in reduced form. We have to do it in a very careful way. So I did it for you for G. I highlighted that in green, highlighted that in green, and that in green. This is built specifically for the three equation model, changing government spending. That's why I highlighted those areas because these are about government spending. And this is a reduced form parameter that captures a change in government spending. So before, all you did was enter in the number. Watch, let me go back, go back, go back. All I did was, this was just a number, right? But here, it's a formula. B48, D41. B48, D41. There's B48. And there's D41. So one's about the scaling and the other is about a change. So how do I use it? Let's go over here. Let's say government spending goes up by 0.1%, all right? Let's say government spending goes up 1%. Well, what happened? B41, which is the government spending in time period T minus 1 before the shock, times 1 plus a percentage change. 1 plus a percentage change is a gross percentage change. If something's going up by 1%, it's 1 plus 0.01. That's whatever is the number times 1.01. If you wanted to grow up by 10%, it'd be 1.1. 20%, 1.2. You always take the number and grow it by that amount. We call that a gross amount. So you can think about this as dollars. Remember, the 100 is just indexed to whatever it is. So you can index that at whatever you want. And that gives me, well, it went up $0.12 billion or whatever it is. That's the actual change. All right. So I had this reduced form and now structural, and I'm augmenting the structural, and that's giving me a change. Why is that helpful? Don't forget, what is this over here? Look at that. Epsilon changed. Why did epsilon change? Because it's linked to D, 41. So epsilon, which captures the change in government spending, is going to reflect the change in government spending. But it's not just linked to it directly. It's also connecting to B48, that reduced form structural multiplier. Why is that? Remember, we just went through this whole thing where you have to shrink the pie so the shares are the same, but still consistent with your reduced form amount. So let's redo that. Rewind the tape. Rewind the tape. Right now, my reduced form structural value is at 12, and pardon me, my structural value is at 12. My reduced form is at 0. No shock. What if that spending on the Trump White House ballroom increased government spending by 1%? Well, in our indexed value, that means that G goes up by 1%, which is 0.12, let's call it billions of dollars. That equates to an epsilon IS shock of 0.06. How do I know it's that amount? Because I scaled that size by a little over 0.5. So that 0.1 scaled by 1/2, that's the 0.06. Now, when I did that, take a look, and GDP went up, inflation went up, rates went up, which is exactly the way in which we thought that it would go, right? Because if they're spending more in G, that leads to more economic activity and more inflation, and the Fed raises rates. Let's see if it also makes sense for the decomposition. Well, we see a big kick in government spending. We see somewhat of a kick in consumption through the income effect. We see a little bit, barely, a decline in investment. Why is that? Because interest rates went up, the Fed increased interest rates, and that curtailed investment a little bit. And you can see it through the decomposition over here. The stacked bar chart adds up to the total. And a big chunk, 0.06 percentage points, was due to G. Income effect, C. Don't forget there's interest rate in there, so that ameliorated somewhat. And then the interest rate effect, the negative going down. And if you want to see the whole puzzle with the growth contributions right there. Okay, so what we were able to do is put that back like that, is give you two approaches. One approach is to start with reduced form, manipulate the reduced form, impose a shock, and let that drip down to your structural model. And you could change that structural model however you want. You could think about multiple parameters inside of consumption, like confidence. You could think about investing in different parts. You could think about G and splitting it up into two components. You would have the reduced form bleed down into the structural. Very informative. What that doesn't allow you to do is move the structural first and see how it impacts the reduced form. That is what this approach does. The key for this one empirically was that it connected, I know it's small, but I want to show you both. It connected your changes in that structural value, in this case for G, all the way up to your reduced form parameter of the IS curve. All right, my friends, hope that helps.